Good evening, everyone. Before we start today's session, please feel free to do event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. I will share the event check-in link with the event ID in the Q&A section shortly. Thank you all once again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. The session will run over the next 60 minutes including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Quick word on our code of conduct. We display this at all Microsoft Reactor events that we run, and it's just a reminder to be aware of others. Key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Amrish, our speaker for today's session. Amrish is a business and technology consultant for more than 20 years. He's currently working with TCS as the Energy Trading and Risk Management Lead, as well as Data Analytics Practice Lead for TCS Utilities. But for now, I will hand over to Amrish to begin the session. Over to you, Amrish.
Yes, thank you, Rashmita. So today's session is about the IPL best batsman and best bowler. I will share my screen. Okay, so it's all here. So what we will do is that so we want to find the best batsman in IPL 2020. Actually, I got the data set for all the seasons, so we can do it for all of them. So maybe I'll show you what the end product is. That makes it easier to explain. So it is something like this. Uh, this is like the app that is here. It is, I think, this is the Kubernetes one. So it is like the batsman, and then you get all the first, second, third until the 10th batsman. You get it, and similarly for every season you are getting it. Once you change it, it changes. And for 2021, you get it. Similarly, for the bowler, you get the same thing. You see, this guy, H. Patel, he debuted recently, right? So he was the top bowler. So you get for all these things. So this is what I am going to show you. Actually, this is the thing that we are going to show. How did I get this? That's the topic for the session today. So this is the end product, and these are the apps which are deployed in this is in Kubernetes and this is in container apps. Sorry, this is in Azure container instance. Okay, so how did I get this? That's the topic that I would show you. So here's the best batsman. So how I have done it is something like this. So I have taken these are the parameters. There is a runs. There is the number of forwards that the batsman has hit, number of sixes, average, and the strike rate. Obviously, there are more factors, and this is a very simplistic approach to it because we know that the runs will depend on the position of the batsman and so on and so forth. So these are the things that I have taken. And all the data, you will find all the data in this site called cricksheet.org. This has got all the data, and if you move around, you will find all the data is there, and it's per match. So you have to collate all the data and you have to get it. So this is a place where you get all the data. So these are the things that I have considered. So if you look at the 2020 distribution of the runs, so this is the plot that I have got. Rahul, Dhawan, Warner, and all these guys are the top run scorers. And then you have the forwards where Dhawan Yadav, Rahul. So these are the forwards that they have struck during 2020. Similarly, sixes, these are the guys, Kishan, Samson, Puran, all these guys they have done. So I have just collated. We'll see in detail of how I have come to this place. And the average is, these are the averages of the people that are there. And then what I do is that then there is a strike rate for all these guys. So there are a lot of parameters. I've simplified and taken these parameters. And then I apply this technique. This is a very interesting technique. So what it says, it is a statistical technique in which you have got a large dimension of things and then you squash it to a smaller dimension. So there are here, as you see here, there are 5 dimensions here. These are 5 dimensions and I have to rank them. So how do I squash it? So the squashing is done through the PCA, and this is one graph which shows that if I squash it to one dimension, it explains around 90% of the data. So we'll go into depth of how we got this and all the stuff. So it is 5 dimensions into one dimension, and then I get this ranking. Similarly, if I do another technique known as a CHT, centuries, 50s and 30s. So this is my fancy formula which I have made. You can make it any formula. So I've made this one metric, like I've given a weight of 2 times to a century, 1.5 times to a 50 and a 30. And this is a CHT. And then I have increased the dimension to another dimension, the CHT. And if you do a CHT dimension, you see that Dhawan has the highest score in that, followed by Warner, Rahul. So this 2020. And then it shows that if you take more than 2 components, it explains 90% of the data. And it's around 3%, it's more than 90%. So I would say around 95%. So 6 dimensions to 2 dimensions, and similarly, more or less the same structure we are getting. So this is the outline of the thing, and I will show you the code and walk through the things that how I have done it. So here I am doing this. So it's a very simple Python program. First of all, is that I have, for demonstration, it's easier to show it in a Jupyter notebook, and then I will show it of how I have converted the code into Python Streamlit app later on, but this is how it is. So you read the CSV file, it has got all the data, and I was showing you like Crick sheet, it has got the individual files. So if you go here, there is some ball by ball information, and then you go here, you have the JSON and the YAML data. So I've forgotten how I did it. Maybe I just converted the YAML into CSV. There is also a CSV format, but what happens is that it is per match data. So you have to do some data processing so as to get this right. So I have collated all of it into some file called all match.details. And this is the data that you would have. You have got a delivery number, non-striker, bowler, runs extra, runs batsman. So every ball data is already there. And then I do a very simple thing like total runs. I group by, do a sum, and then these are the runs, and then I use, so don't worry about the code. I'll check all of this into GitHub after this session. So this is the draw plot, and then I have a very standard way of doing these plots, meaning once if you follow the, it's like get a figure, put some ticks, get the label, set the Y label, X label, set the title. So this is a standard thing that I have done, and then I use a Seaborn library to draw the plot, and it's a bar plot. So this is how I'm getting. So you saw on the PPT all those things. So this is what is the uh, thing that is there. Similarly, the matches, all these things, it's a group by and then a count. So if you're familiar with SQL, Python has a very good way like pandas, and you can use these type of things like a group by count, and you get this number of matches, number of outs you can get, and I can get all the outs here. Then the number of fours uh, where the batsman's run is 4. So I get to hit the number of fours, and then the similar technique in which I show the batsman fours. Same technique. It follows a theme. I do a draw plot, I do a bar plot, and then I enumerate, and then I do some coding to place the number of fours here. So these are the number of fours. Sixes also same. Runs batsman 6. Here is a code for that. Average and the strike rate. So the average is first I get the number of deliveries, and then I do some merging with the data, and then I do the number of times the player was out, because I don't want to count the times he was not out. So this is the way I'm getting the average, and the strike rate is very simple by the deliveries, and I do this. And then this is the average distribution, same concept applied. The strike rate also done in the similar manner. And then this is a PCA. So PCA, we said that this is a dimension reduction problem. This is a very useful technique which is used widely in industry when you are having, say, thousands of dimensions and you want to squash it. Here it is very easy. It is only 5 dimensions and I want to get a ranking. So what I'm doing is that this data set out here, the batsman all stats 5, you see it has got 5 dimensions, 1, 2, 3, 4, 5. So now I need to squash it into a single dimension. So this is what the PCA is doing, and I'm using first I scale it so that everything has a mean of 0 and a standard deviation of 1, and then I transform it to do a PCA. PCA is from the scikit-learn library, and then this is what I am getting. And then I sort the values in the ascending order as a descending order. And this is the PCA that I'm getting. And this one is a code which shows that, see, one thing is that the question and the paranoia that you would have is that if I have so many dimensions, I am reducing it to 1 dimension. So am I losing out any information? So this we can use some technique called the explained variance, and this shows of how we are getting that it shows that 90% of the data is being explained through around 2 components, 1.5 components. So this is one part which is before the 30s and all those things. So this is more code out there to explain the 30s, and then I've got the 50s also. And similarly, the 30s, the number of 30s the person has scored. Similarly, the number of 50s. This is very non-optimized code. I have optimized it in my uh, Python application. So 50s are there, and then centuries are there. And then I have got more dimensions out here. Uh, and then some more manipulations. And then I calculate the CHT through this. So there are more calculations like I was showing you, right? This part, the CHT calculation. So this CHT calculation is shown in the code out here. So this is a Chd calculation, and the PCA is the same thing. Only thing that I have done for the PCA, I have taken batsmen whose runs are greater than 300. I do not know why, maybe some median I thought. Um, and same technique applied, and this is a PCA, and also around two components we are showing it, and here we see that these are the guys who were there. Same thing what I have done is that I put into a Streamlit app. This is a Streamlit app. Streamlit app is, it has, so what I have done, all the code that is there, so that's all over the place, and I have to wrap it over a Streamlit UI. So basically all the code is here. So it has got a .py file, which all the code that you are seeing is all in the Crickstats Python file. Nothing fancy, a more arranged way of doing things. And then I've got one UI out here. So you see that I have deployed this thing in Azure container instance. I'll show you of how I have deployed this thing in container instance. And so this is the one that the batsman part. So you can choose any season, play around with it like anything, your favorite. Maybe this app needs to have more improvement, like your favorite batsman, how did it go? Because you've got all the data. You can make it your, so if you are into all these fantasy league stuff, I know some people play, I am not into it, but maybe you can use this type of, the data is, I'll push in the code, you'll have all the data, you can extend this. Streamlit is a very easy tool in which you can do something. So this is what is the thing. I'll take a pause before I go into the bowler thing. What I'll do is that I'll go into the bowler, I'll explain the bowler stats of how I have created same technique, slightly different parameters, and then I'll show off how I deployed this in ACI and AKS. So I'll just pause here and see if there are any questions. Hmm. Okay. Okay. So anyways, we don't have any questions till now. Okay. So this is, so for the bowler, what I have done is a similar technique out here.
Hey Amrish, I have a question.
Yes,
Uh, so you were using two techniques, right? To do this,
yes.
or
So I was using just one technique known as a
one technique?
PCA. PCA. So
Why
PCA.
why why
Huh,
did you choose that one for this specific use
okay.
case? Is it something which is
Okay.
recommended,
Yes,
or
that's a great. Oh, why did I choose? So, this PCA is a technique. It is a statistical procedure which tells you that if you have a lot of dimensions, right? So for us, these are the dimensions that is there um, in our thing, right? Where is that? These are the dimensions. Rather, the more dimensions, I will show you that. These are the dimensions that we are having. But I need to rank, like, who is the best batsman in your, uh, what should I say? How do you rank them? But there are so many parameters, right? So I do not know which parameter would be the best. So instead of relying on cricketing expertise, I let how does the data show that which is the most dominant way of expressing the ranking. So this is a good technique of dimension reduction. It is specially used like if suppose if you have data with thousands of variables and you want to squash it into a reduced number of variables, then this technique is very useful. So here in this case, my ranking is 1, 2, it is one dimension, and I have got 6 dimensions here. So that's why this technique is very useful. Okay. So obviously this is a very simplistic way, as you can say, because there we should consider the position of the batsman and so on and so forth. But this is one way in which we are doing. Vivek, does it make sense or does it answer?
Yes, yes. That was good. Yeah, got it.
So this is one technique. The other one that the bowler one is similar. It is like the 2020. Here, what I am considering is that the wickets, the strike rate, and the average runs per wickets, and the economy, which is the runs per over. And this is how you can do. And you see Rabada being the best here, and then you have Bumrah, and then you have Holder for the strike rate, and Rashid, and also the same technique, reducing 4 dimensions into 1 dimension. So, so uh, in if suppose if you have a problem of many dimensions, this technique will help you to squash it into a single dimension. It's a very good technique in which for machine learning, because say suppose if you have a data set with a lot of parameters, lot of dimensions, and your algorithm will find it difficult to manipulate all these things, then you can squash it to a smaller number of variables and apply your algorithm over there. This is a good technique. So bowlers is the same. So here my dimensions were 4 and I squashed it to 1 dimension. So the similar way here, if I take one principal component, I explain 95% of the data. So that's what it is showing. And then this you see the Bumrah, Rabada, Bolt, Chahal, all these things it is coming. So the best thing is that I am letting the data speak for itself, and you can rank it on in this manner. And so this is what it is. And similarly, there is code for that. And if you see, if I go to the bowler part also, you see here these other things like which is coming up. So 207, who was the best bowler, Sohail Tanvir, Pathan, and all these things, and 2021. You will have all these things. Similarly, you can do more to like the thing that I showed, right? Most wickets, all those things that I was showing you. You can play around with this app. So this is the app that Streamlit app. It is there. And I want to show you of how I have deployed this whole thing in Azure container instances and as Kubernetes services. So what I have done is that, so this is the app. If you look at it, don't worry, all the code, I'll check it into GitHub. Basically, all the UI code is in one place, and it's a very simple way. Some radio boxes and all these things are there, and this has got all the code that we were seeing. So lots of code, and then what we have done is that we have deployed. First, I'll explain the Azure container instances. So before we do that, there is we have to write a Docker file. And before we have to write a Docker file, there is something called the requirements.txt. So this lists down the libraries that this app is dependent on. So first is a Streamlit. I've used Pandas, I've used sklearn, Matplotlib, and Seaborn. Very simple thing. Then I have written a Docker file. So this is a Debian image, Slimbuster, very small Debian image. And then I copy all the files together. And then I install the requirements.txt. And I expose 8501 because Streamlit runs on this port, 8501. And then this is the command that is run, Streamlit run IPL.py. So this is the Streamlit app that is there. So you have to do the requirements.txt first, then do the Docker file, and that's it. And then you build an image. How do you do it? Docker build -t IPL dot. You can just do it here. So I am in my box. So I can go to my file. So these are the things you have to do. Docker build. What was the thing? Sometimes I forget. -t IPL dot is important. You have to run this. I've already built it. So it is already there. I'll show you my image. Where is my image? So in your machine, you need to have Docker installed, or you can have a machine in which you can install Docker. So I already have this image. See IPL, I already built it. So it's a voluminous image, 1.3 GB. And then what you can do is you can run it in your own machine. So I can run it now in my own machine since it is already there. I don't know, sometimes it takes time. So this is the way you create the image, and it is, so it's running. So what you do is that you go here, you can do a local host. You can check before you deploy. So the same thing is in your machine. So it runs in your machine, and then what you do is that then you go and do the steps. So what are the steps? So for the ACI, it is something like this. You create your resource group, that is the IPL group. So it is here. If I go here and this is my resource group. I have already got this group. And then what I do is that I create the container registry. The container registry is here, AGI. So I've created the container registry also. So where is the container registry? I've created the container registry. Container registry is here. And then what I do is that I will show you is you log into the container registry, you tag the image. This is the latest, tag the image to the container registry. So once you tag it, if you run this command, what would happen is that this thing gets tagged here. It's the same copy that gets tagged here, and you tag it with a V1, and then you push it into from your local machine, you are pushing it to the container registry. You push it here, and let us see where is the push. Here is the push, and I pushed it here. It takes some time. It's a heavy image. So I push the image. All this is pushed into the container registry here. And then you update the container registry, you get the admin, you get the password, and then you create the container app. So this container app, you see, you've got the group, you've got the image, you've got the server, you've got Central India, and then once you run it, this becomes the container app, and that is what we are seeing it over here. This is the app that we are seeing it. So it's running as a container instance here. Okay. Now the same thing I have done in a Kubernetes cluster. So in the Kubernetes cluster, what we have done is that steps are the same. Steps are the same. Only thing is that this part I had to create a service principal. I don't know why. Usually I don't have to create, but while before just preparing the demo, it gave me an error that the Kubernetes cluster was not able to pull the image. Sorry, this when I'm creating the cluster, it was not able to pull the image from the container registry. So I looked up and they said that it's better to create a service principal. So a service principal is created, and what it does is that I give it a role. I give it a create RBAC, which is role-based access control. And here you see I give it an ACR pull permission so that it can pull the image from the container registry. I get all these values, the username, password, and then I do a very simple thing. I create a cluster, and the cluster is only one node. So once I create the node, one node, I'll show it. It takes quite a bit of time to create the node. So we'll see that how it is after you run this command. Don't worry, all this code I'll check it into GitHub. So this is the cluster that is there. Now the cluster is there. It is a one node pool cluster that is there. And apart from this, what I do is after I create the cluster is that I get the credentials and then I use kubectl apply -f ipl.yml. So the YML contains the deployment as well as a service. So those who are familiar with Kubernetes, what happens is that you have to have a deployment part and you have to expose a service. Okay, so let's look at the YML file. So the YML file is very simple. It has got a deployment. It has got how many replicas you want to have. So I've got 3 replicas, and the image is this IPL image, the name of the image, and this is my location, and I want to run it at 8501. So this is what you see how it is. This label web here, this deployment web refers to this label of the app, uh, which is a label of this image. So this is the image that was pushed. So I've got 3 replicas here, and I expose all these pods are running in the Kubernetes cluster. And now I have to expose it because, as you know, the pods can be killed, but the service remains the same. So I will expose it as a service, and this is a load balancer service, and it runs at 8501. It's very simple. I have done it beforehand. So where is the thing that I have done? All these things I have done beforehand, before the our demo. So all this is running fine. So you see all the steps that was mentioned. It is running here, and now let's see. I just want to show you. So I said three replicas, right? If you do a get pods, see there are three things running. You see the kubectl get service. I am very amazed by this configuration that I did for the my shell. See, so nice. It gives me even the cluster that I am running in. So get service. So this is external IP and this is a port. So if you see here, I'm running it in this port here. 20 point, this guy, and this guy is the same. So this is how I'm doing it. So this, and you can play around. You can see of how we can see that how if we can kill a pod. How do I kill a pod? If I kill a pod, then I'll see one pod running. I just want to have a delete pod. Let me just see. Let me just see. Let's have some fun. If I delete a pod, will it kubectl? say it's deleted. And then if I write kubectl get pods, what does it do? Immediately see the age, this new pod has come, this is a new pod, and this pod has gone away. S2 is not there. It's like instant, it is creating the thing. Let me kill this one, Z6. So this is how you see the power of scaling up apps. Z6 will be gone. Anyways, so that's the thing. Let's get pods. Wow. So that's it. You create an app, a machine learning app. Obviously, this has got some limitations. First limitation is that it's quite simplistic. Second limitation, it's a monolith. So you want to take the UI out and create a service out of it, make it a microservice or create two separate things. That would be great. And you can add more functionalities. And so that's more or less the thing that I was going to show you today. Next session, what we will do is that I've glossed over the PCA. I used Python to just gloss over and show that how the PCA is. Next session, what I'll do is that we'll go deep into PCA. What is PCA from linear algebra and all those things? But it's easy. What you know from class 9, 10, 11, 12, I'll use those concepts and we'll see of how we can understand the inner workings of PCA of that. But this session was more engineering and a little bit of ML focus. So that was the intention, so that see of how it is easy to develop apps and also expose it and also scale it using Azure container instances and Azure Kubernetes services. So I'll take a pause. Hopefully it's a monologue and any questions?
I mean, Amrish, up to how many dimensions we can look
I think
into? Like
I
if I
think
have
any dimensions,
a number
any
of dimensions.
dimensions, n number of dimensions. See, in these Kaggle competitions, what they do is that they will have a huge data set with huge number of columns, and then they would squash it. And I have seen one very interesting technique is that sometimes they would not even they would select some columns. Say suppose there are 100 dimensions, they would select some columns because of domain knowledge, so 50, and they would add this PCA on top of the 50 and it would increase the accuracy. So because this adds a lot of information, hidden information of the data into the thing. So that's why it is a very interesting technique. So,
Got it. Got it.
mm. so so that's more or less I have for today. And the next session we'll go into what is PCA, how is it we can do it from first principles and so on. And I will check in the code in GitHub, all the code, so that you can use it and extend it and see of how we can deploy in container instances and Azure containers, Kubernetes services. So one thing is that you see that if you want to compare compare batsmen, compare Virat Kohli versus AB de Villiers, you can use this technique also, because you gather, say, you can extend it. You gather all the data of AB de Villiers, you gather all the data of Virat Kohli, you gather all the data of Rohit and you put it into one massive data set, and then you take these dimensions and then you squash it into a single dimension and see who is better. So this is a great way in which you can um, see and play around with it once I check in all the data.
Yeah, Ambrish, one question regarding the Azure deployment, right?
Yes.
Yeah, can you show the list of files, right? If we
I,
used to get
I'll
some
I'll check in.
files.
I'll check in the
Yeah,
thing.
yeah. In
Uh,
that, yeah, I have a question on that. The steps, right? Azure ACI steps.
ACI steps.
Yeah.
Yes.
So these steps is a one-time work, right? Where we need to create a container register, everything is a one-time work, not on every time. Say, for example, if I update the code and I'm pushing to again to the Azure portal, so this
Mm-hmm.
steps is not needed. Am I correct?
Yes, you may not need. Yes, you may not need all these steps because this is the only step that you would need. Rather, I think there are certain you need to log in. You need to log in, and then you need to get the. I think these steps would be needed. Log in. You get the admin enable password, and then you create this thing again. And before you create, might as well delete the previous container.
Yes, so if you're building this in production, you don't need all these steps every time. It's just
Every time.
one time. Once you
Yes.
have set up everything, is just that you're pushing code to GitHub and it is all getting packaged and it is getting deployed.
Yes.
Oh,
That's
okay.
hmm.
Either you can use GitHub Actions or
Yes.
Azure DevOps pipeline. So any of those tools is to make sure that everything is automated. So this
Exactly.
is, yeah, I mean, these steps are like if you are getting started for the first time, you need to know what all needs to be done. So that is the list of steps which has been provided there. But in production, you don't need that.
Okay. So one more question, right? Future, is there any extraction? Say, for example, what are the columns from the data set
Mm-hmm.
you are eliminated?
Hmm.
Can you little bit talk about what are the columns you removed so that it will be helpful for our accuracy or performance?
Yes. So what we are doing is that uh, this this one, right? So huh. So these are the ones. So these are the fields that you are having. Hmm. Now you'll have to see that this is the data that we are having, and we can see what are the columns there. So let me just say what are the columns. So these are the columns you're having. So it depends on how creative you can be actually. Okay. So, and you got the whole data. So one thing that I would be interested is that here I made it very simplistic is that I have not considered the position of the batsman because the position is very important. So you can play around and include the position of the batsman by looking at the data set, in which position the batsman is playing, and have some weightage on top of it and do some manipulations on that. That
Got
would
it.
be, I think that is a great thing that you can do. One good thing, since you say about this, check out ESPN Cricket Info. They have a way of analyzing who is the best batsman. So that's more complicated, I think. They analyzed that in a given situation, uh, in the same situation, they would give points how
Okay.
that person
So
is. Hmm.
okay. So my intention of this question is right. Say, for
Yes.
example, assume that I'm a batsman. So
Hmm.
I want to analyze, okay, what are the things is going to help in order to become improve my battings, right? Say for example, my position or my over, which number. So those information as a batsman will be helpful. So that's the
Yes,
point
yes.
I'm raising this
Yes,
question.
yes, that is very easy because you have got the ball by ball data, right? So if you say, if I am say Shubham, so I would take this data set and I would do some manipulations on it at in which position. So you can have one analysis, say Shubham, position one, number of balls faced, number of runs scored, um, and what is strike rate and blah blah and all these stuff, provided the person plays in different positions. You can have that analysis done.
Yeah, fine.
And more so, I think what I have done is that if you check this data is full data. I think I have made some, or it was given. So this data has got everything for all the seasons or something. I have to see of how I have done it. Oh, this is full data. So this is a full data. You have got the full IPL season data out here, and I'll check in this code, and you can see of how you can play around with it. And then I use this technique, maybe this data, to create my Crick stats thing, IPL.py. So all the data is available. You can play around with it, and it would be nice that if once I check in, it becomes an open source and you can fork it. You can do a lot of things, and it has got a very simplistic UI, uh, but you can always make a much more better UI than me, uh, React and all these things. So, and all that is available open source. So
Yep, fine. Thank you.
yes, I think meaning there is a lot of things that we can do as a community with this type of projects like cricket. Everybody knows the problem with data science that I find is that domain understanding is the most important thing. People know algorithms and they will make 0.00001 accuracy and all these type of things, but ultimately at the end of the day, if you don't know the domain, it becomes very difficult to do anything. But cricket is, as all of us here from India, we understand the domain very well. We understand which position the person should play and all these things. So it is a very good way to start off and to have a community project around it. Yes, if suppose if you do not have any questions, then we can wrap it off.
Thank you.
Mhm.
Yes, Rashmita, you there? Yep.
Thank you, Amrish, for the session, and thank you all for joining us today. Please feel free to do event check-in and share your feedback about today's session. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again and enjoy the rest of your day.
Thank you. Thank you, everybody.
Thank you
Bye.
all. Bye bye. Thanks, Amrish.